Today's learning target is I can find the prime factorization of a composite number. A prime number is a whole number that has two factors, one and itself. So when we talk about factors, those are the numbers that we times by each other. So for example, 2 is a prime number because the factors of 2 are 1 times 2. Okay? 3 would be a prime number because 1 times 3 are the factors, and there aren't any other factors that I can use to get to 3. 4 would not be, and we'll see why in a second, but 5 will be because 1 times 5 are the factors. 1 and 5 are the factors of 5. 7 would be another one. 1 and 7 are the only factors I can use to get to 7. A composite number is a whole number that has more than two factors. So when we look at this, 4 is a composite number because the factors I have are 1 and 4 and 2 times 2. So the factors of 4 are 1, 2, and 4. Okay? 6 would be a composite number because I can times 1 times 6 and I can do 2 times 3. So the factors of 6 are 1, 2, 3, and 6. 8 would be because there's more than two factors. I can go 1 times 8. I can go 2 times 4. So that one has 4 factors. 1, 2, 4, and 8. We're going to take a look today at what's called prime factorization. And prime factorization is expressing or showing a composite number as a product of prime numbers. So what that really means is we're going to be showing composite numbers and what prime numbers you multiply to get to that composite number. So let's take a composite number like 60. So I know 60 has more than two factors. What I'm trying to do is I'm going to try to figure out what prime numbers I multiply to get to 60, but it can only be prime numbers. And I create what's called a factor tree. Okay, so a factor tree just looks like this, where I'm going to say, okay, I'm going to take two numbers that I know that equals 60. It can be any two numbers. So I'm going to do 2 times 30. I know that equals 60. Now, 2 is prime, so I can't break that down anymore. But 30 is not. I can still break that down more. So I know that 30 I can do 2 times 15. Okay, that would give me 30. Now I've got another prime number here, but 15 is not prime because I know that I can take 3 times 5. Okay, now I look at this and 3 is prime and 5 is prime. So my prime factorization for 60 is 2, 2, 3, and 5. Now I could check that by timesing these. So let's just try it. I know 2 times 2 here. Actually, I'm going to do it this way. I'm going to go 2 times 5 is 10. And then 10 times 3 is 30. And 30 times 2 is 60. So yes, when I times those, I get 60. So this is called a factor tree. Now if you look over here, you can see that I used a factor tree to do 60 again here, but I chose different factors on the first one. Now you see that makes just for different factors, but it doesn't change my prime factorization. I still have 2 and 2 and 3 and 5, just like I had over here. So it doesn't matter what numbers you choose to multiply as long as they're factors of that number. If you do it correctly, you'll get the right prime factorization. And when I'm writing my answer for this, I would do it just like this. 2 times 2 times 3 times 5. So I've got them in the right order right up here, and now I just show that like this, so that it shows that when you multiply them, you would get that number. So that's how I would show this answer. One other way you could write it, because there's two 2's that you're multiplying, you could do 2 squared times 3 times 5. Either one would work. If I'm asked to find prime factorization of this problem, something like this, here's how I do that. So I'm going to split up the 12 and the variables x, y. And now these just split up x and y. And now I just go to my 12. Okay? So I could do 3 times 4. And I know that 3 is prime, so I'm going to go with that 4 though, because that's 2 and 2. So the prime factorization for this is 2, 2, 3, x, y. And you notice when I write my final answer, I put them in order. So even though I had 3, 2, 2, so I go 2, 2, 3, x, y. So when I'm writing my final answer, I would just do 2 times 2 times 3 times, oops, I'm going to use a period there, times x times y, like that. Or if I wanted, I could do 2 squared, because there's two 2's, times 3 times x times y. Either one of those would be the perfect answer.